So if you don't want to be on tape. Okay, list the factors of 24. So once again, I like to see it as factor pairs. 1, 24, 2, 12, 3, and 8, 4, and 6. And 5 doesn't go in, and 5 is the only number between 4 and 6, so I know I'm done. Okay. Number 2, 3x equals negative 11. What do I do to solve that?
Divide by 3.
Divide by 3. I'm not a raise your hand and answer kind of person. I'm a, if you know the answer, holler it out. Everybody holler it out kind of thing. That's just who I am. I've never been a, oh, you do it and you do it. Every once in a while I'll call on somebody, but yeah, usually I don't. Negative 11 thirds. Once again, please leave them as an improper fraction. I'm good with that. That's what I prefer. Okay. Let's see if I can extend the page to move it up. So k divided by 4 equals 2. How do I solve this? Times 4, multiply both sides by 4, and I get k equals 8. And the last one, what do I do? Add 5 to both sides. So I add 5, w equals negative 3. Okay, watch your negatives and positives. They are important. Okay, if you have negative 3, if you go to the bank and you go to deposit the $300 paycheck and your bank, instead of depositing it, which is a plus, they put a minus in front of it and take $300 out. Ooh, that's a big difference, and problems will happen because of that. Yes, little minuses and pluses make a huge difference. Okay, big difference, very, very big difference. Okay, so what is the reciprocal? What you multiply to get 1. Flipping the fraction is how you find it, but technically a reciprocal is what you multiply a number by to get 1. A number times its reciprocal will always be 1. That's what a reciprocal is. And a reciprocal isn't just a numerical value. You can have reciprocals of anything. Variables, all that kind of stuff. It's what you multiply to get 1, and you need to write that down in your notes. Okay? And you're welcome, I typed it in there instead of having to read my crappy handwriting. You're welcome. Okay. Anybody in here colorblind? Blue, green, red, green? Red, orange, okay. That's not too bad. I had one year I taught, and I had a green chalkboard, and I was doing geometry, and with geometry I used, color is really important. And I had a green chalkboard, and I used red chalk. They're writing on the green chalkboard with red chalk. And this girl is perfectly well behaved, never talks to her, and she starts talking to the girl next to her. Like, what are you doing? And she didn't say anything. And then she said, what are you doing? She goes, I can't see what you're writing. I said, I'm not standing in the way. She goes, I'm red-green colorblind. I go, really? She could hear the chalk going across the chalkboard, but it was like I was writing with invisible chalk. She could not see it at all because she was red-green colorblind. Yeah. Like, okay, tossing the red chalk away, so I'll do that one again. But yeah, that was cool. Yeah, that was tough. Okay, so I want to find the reciprocal. It's not that hard. Like I said, invert the fraction is the easiest way to find the reciprocal. So the reciprocal of 4/3 is 3/4. The reciprocal of 6/7 is 7/6. What is the reciprocal of 8?
1 over 8.
1 over 8. Because 8 as a fraction is 8 over 1, so it's 1 over 8. The reciprocal of negative 2/9. No, it's negative because I want to be able to multiply it to get a positive one. Your reciprocal has the same sign. So it would be negative 9 over 2. Negative 9 over 2 because it's what you multiply to get 1 and it's multiply to get positive 1. So if your number's negative, your reciprocal is also negative. That's an important thing. Okay? Your turn. Do those 4. If you have not done already. If you have done already, good. If not, still good. So I hope some of the stuff is easy, but these are also important things that I really want to make sure you know what you're doing and you're getting it right. These are the basics. Got to have the basics down. Okay? If you have issues, if you have problems, do not hesitate to talk to me. If you don't want to talk to me during class time, you don't want to raise your hand and say, Mr. Orris, I didn't get it, Fine, come up to me later, talk to me later in private. I don't care. That works for me too. I understand not everybody's like, I didn't get it. A lot of people don't want to say that. You know, but usually if you don't get it, there might be somebody else that doesn't get it too. Say something to me. Talk to me. Communication is important to our relationship. Okay, and I can't, if you don't tell me, I don't know necessarily that something's going wrong until I give you a test. And you don't want to wait to that point. Okay? So, reciprocal of 2/3, 3/2, reciprocal of 5/2, 2/5, reciprocal of -1/2, -2, and reciprocal of -1/9 is -1/9. Easy peasy. Okay. To solve a problem with a fraction in front of the variable. So when we did the other problems the other day, it was always do the opposite. If it's addition, you subtract. If it's subtraction, you add. Multiplication, divide. Divide, you multiply. If you have a fraction in front, multiply by the reciprocal. Because the idea is I have 2/3 F, I want 1 F. I want to know what 1 F equals. So I need to take that 2/3 and make it 1, which is why the definition of a reciprocal is what do I multiply to get 1? Because I want 1 F. I want 1 K. I want 1 H. I want 1 P. How do I get one of those? I multiply the fraction in front by its reciprocal to make it 1. So I multiply both sides. And what do? I always have to do both sides, right? So this one I'm going to multiply by the reciprocal of 2/3, which is 3/2. Okay. So multiply this side by 3/2 and multiply this side by 3/2. And yes, there's multiplication of fractions, but they're not that difficult. Okay. And like I said, these cross cancel and I get 1 F, which is what my goal is. I want one of my variable equal to something. I want to know what one of those is. So I get F equals, and then make my 5 a fraction just to make it easy for multiplying fractions. Multiply across. 5 times 3 is 15. 1 times 2 is 2. I get 15/2. So I'm good with 15/2. I like improper fractions. I'm comfortable with it. Okay. So, what am I going to multiply this one by? 3/8. Multiply by 3/8. I'm not going to make you write in words every single time, but I do want to ingrain some of this stuff into your head. So I'm going to make you do it occasionally, but I'm not going to make you do it every time. So I multiply both sides by 3/8 times 3/8. Those cancel. I get K equals 4/1. Now I have 4/1 times 3/8. More than one way to multiply these fractions. I can multiply and then reduce, or I can cross cancel and then multiply. I prefer cross canceling first because cross canceling tends to deal with smaller numbers. If I multiply first, then my numbers are larger. It's much easier to reduce something that's small than something that's large. Does that make sense? Bigger numbers are harder to work with than smaller numbers. So I look at this and I go, oh, I can cross cancel. I can reduce ahead of time. 4 goes into 4, 4 goes into 8. 4 goes into 8 twice, into 4 once. 1 times 3 is 3. 1 times 2 is 2. I get 3/2. Easy peasy. Okay. Piece of pie. Easy as cake. Cake's easier than pie.
I guess. I know how to cook this pie.
Okay. So what do I do on the next one? I multiply by what? Multiply by 2/5, 2/5, 2/5, Cross cancels, I get h equals. And I can reduce this one as well. 2 goes into 2 once, 2 goes into 4 twice. 3 times 1 is 3, 2 times 5 is 10. But once again, I could have, and actually I'll do it on the next one. I'll multiply and then reduce just to make sure we get an example of that. Because either way is okay with me. As long as you get the right answer in the end, I'm okay. If more than one method is viable, I'm okay with either method. I really don't care as long as you get the correct answer using good math. Does that make sense? Not bad math, good math. Okay. So on this one's a little bit different, but it's not bad. Multiply by, what's the reciprocal on this one? Negative 8. And I might want to make it 8 over 1 just to make the reduction easier. Does that make sense? And it has to be negative because my original number in front of the variable is a negative, so I have to multiply by a negative. So I had negative 8 over 1 times negative 8 over 1. Those cancel, I get p. And then if I multiply first and then reduce, not a problem. 1 times 8 is 8. 4 times 1 is 4. Don't forget the negative. And then I can reduce that fraction. 8 and 4 are both reduced by 4. So p equals negative 2. Okay? Questions? Like I said, I know we're taking baby steps now in a lot of ways, but this is also really important stuff. Because being able to solve equations, there's like 3 or 4 real cornerstones to success in algebra. Being able to solve an algebraic equation for a single variable in any form is huge. It's a really big thing. Success in geometry. Being able to solve problems like this. In Algebra 2, being able to solve problems like this, what we're doing this first couple of weeks, being able to do this stuff is a really big deal. Making it second nature, making it easy for you, that's my goal. Because I want you to have success in the classes after this. Not just here, but after this. So I'm making sure you get down the things, the cornerstones that you need. That's really my goal. Okay? It's your turn. Do these 4. And please do write out in words what your steps are. Okay? Everybody's done. Okay, so the first one. Multiply by what? 6 fifths. 6 fifths. 6 fifths. I get d equals, and there's no reducing on this one, so that's 48 fifths. Okay, the next one I multiply. What do I multiply by on the next one? 7 over 2. 7 over 2, 7 over 2, and I get p equals 1, 2, p equals 14. Okay. And then on the next one, what do I multiply on this one? 3 over 2. And I flopped it on purpose because everybody always gets used to the variable always being on the left-hand side. Well, it can be swapped. It can be anywhere, on one side, the other side, anywhere in the equation. So I multiply by 3 over 2. So 3 over 2, 3 over 2 gives me 27 over 2 equals h. And that's okay to have it this way. If you wrote for your answer, h equals 27 over 27, 27 over 2. If you wrote h equals 27 over 2 instead of 27 over 2 equals h, I don't care. They are equivalent. Equivalent means not the same, but equal. Yeah, they are equivalent. These are equivalent answers. I don't care which side of the equal sign the variable is on, as long as it's all by itself and there's numerical stuff on the other side. That's what I care. Okay? And I know that some students get hung up and a few teachers get hung up. Oh no, you always have to have the variable equals this. I don't care. Because the variable is equal to that. H is equal to 27 over 2. So they're equal to each other. Doesn't matter which side of the sign they're on. As long as you have those two things, and one's on one side and one's on the other, you're good. Okay? I don't expect anybody in this school to be picky, but I have seen other teachers at other schools be picky, and I know some kids get really hung up on it. I don't. Okay? I multiply by what on this one?
11 over 6, negative 11.
Negative 11 over 6. Gotta watch your negatives and positives. Negative 11 over 6. Negative 11 over 6. I get t equals. I had two negatives, so my answer is going to be positive, which is nice. And the 3 and the 6 reduce. It goes in there twice, goes in there once. So I get 11 over 16. Any questions on that? 11 over 16. Good? If you do have any questions, like I said, don't hesitate to bring it up. Don't hesitate to ask. And I might screw up. I do it every once in a while, even on the simple stuff like this. Okay, I will screw up every once in a while. Usually because I get too enthusiastic. Okay, now we're going to start working on two-step equations. Rules are fairly simple for two-step equations. To solve two-step equation, generally speaking, first you solve the addition/subtraction portion, then the multiplication and division, unless the entire expression is being divided, and we will have an example of that. Then you multiply to remove the division, and then solve the equation that is left after that. Okay. So generally speaking, when you're solving equations, two-step equations, you're doing the opposite of the order of operations. Order of operations, you do multiplication and division before you do your addition subtraction. When you're solving it, you're doing it in the opposite order. You take care of your addition subtraction first, and then your multiplication. Technically, you don't, but it's a lot easier if you do it this way. You can divide everything. I can, on that first problem, divide everything by 2 first. It makes it harder. And we want to do things the easy way, right? I try to show students, okay, there's more than one way to do it. This is the way that will be the easiest way and the one with the least complications, least possibility of error. That's what I'm really after. I want to give you the fewest chances for error as I can when I show you more than one way to do something. I show you steps. I want to make it as easy as possible. Okay? So, first I'm going to take care of the addition and subtraction. So what is my first step in this problem?
Add 5.
Add the 5. So my first step, add 5. And I do want you to write it down. So I add 5 to both sides of the equation, just like I did before. The 5's cancel, and I get 2x equals 5 plus 9 is 14. And it's called a two-step equation because I have to do 2 steps. What's my second step? Divide by 2. And write that one down. So I divide both sides by 2, and I get x equals 7. Yay. Easy peasy. Often on things like this, I will use more than one color for more than one step. I have students that do this in their notes. Most don't really care. But generally speaking, if I do something like this in more than one color, it might be helpful depending upon your needs and abilities to do it in more than one color. But like I said, it's not that big a deal. I've had students that have laid out several different colors of pens, and they're matching what I write literally on the board. Okay, I do multicolors to separate steps. It makes it easier for you to visualize what's going on. You don't have to, but when you're looking at this, it kind of helps. Okay, second problem. I'm going to go ahead and extend the page to move it up to the top. Same idea. What's my first step on this? Subtract 7. So So I subtract 7 from both sides. I get 3x equals 4. Right? Yeah. Okay, what's my next step? Divide by 3. So I divide both sides by 3. And I get x equals 4/3. And you're going to have a lot of problems in here. When I'm making up the problems, you're going to have a lot of them that end in fractions like this. I don't care. It's not a big deal. Do not expect everything to be nice, perfect, and come out easy peasy whole numbers and all pretty. No, fractions are fine. We're going to get a lot of fractional answers in the end. Okay, so get used to it. Yeah, I know. But you know what a 3 is, though, right? Yeah. Okay, then you've deciphered the code. The hieroglyphics, as I should say. Okay, we're still going to be doing some of these together. These are still examples doing together. My first step on the next one. Subtract 4.
It's like the third time today.
So I subtract 4 from both sides. F over 5 equals -7. And then what do I do? Multiply by 5. Times 5 times 5, and I get F equals -35. Okay. So, next one. Over here. What do I do first? Subtract 5. Three has J equals -1. Ooh, that's nice. Multiplying by -1 is easy. Okay. And then what do I do? By the reciprocal, which in this case the reciprocal is 2/3. Multiply by 2/3. 2/3 times 2/3. J equals -2/3. Easy peasy. Try to do one of every possibility. The numbers will be different to protect the answers, but every one of these, add, subtract, multiply, divide, I tried to give ones of every possibility. Now this is what I was talking about, where the entire thing, this is the exception to getting rid of the addition and subtraction first, because the entire side is being divided by. So instead of getting rid of the -5 first, I need to get rid of the divided by 2 first. The key is the whole thing is being divided by 2. If it was just k divided by 2, you know, like this one here, it's not the whole thing is being divided by 5, just the variable. This one, the whole thing is being divided by 2. That's why, you know, when we go back to here, the entire expression is being divided. The entire expression is being divided. So my first step here is actually multiply both sides by 2. Times 2 times 2. Now, on the left hand, or sorry, the right hand side, it's really easy. That's equal to -6. This is where students get confused, and part of the reason I really want to talk about this is this can be confusing. I see Algebra 2 students struggle with this problem. I've seen calculus kids, and you know, they know their stuff pretty good. I've seen them screw this one up. Okay, not very often, but I have seen them screw this one up. The multiplying by 2 strictly cancels out the denominator. Okay, the k minus 5 still stays k minus 5. It is not k minus 10. The 2 cancels out with the entire denominator. That's what we're trying to do here. So I end up with k minus 5 equals -6. Okay. Now, this is two-step equation. What's my second step? Add 5. Add 5. So I add 5, add 5. K equals -1. Okay. So, similar example. What's my first step on this one?
Multiply by 8.
Multiply by 8. Times 8 times 8. Those cancel and I get 5 plus r equals 16. Ooh, how many of you are thrown off by having the variable not in the front? Oh, good. No hands. Because that is one of those things, I don't know how to do this. Never showed me how to do that. Yeah, it's not that big a deal because it's addition, it's not subtraction. I need to get rid of the 5. How do I get rid of the 5? Subtract 5. So I get r equals 11. Oh, you'd be surprised. Well, actually, you probably wouldn't be surprised if I have students get all worked up about. Okay? I've had students where I did a problem 2x plus 3 equals 5, and the next problem is 2x plus 6 equals 11. I don't know how to do that. I just showed, just because I changed the numbers, I don't know what to do. Yeah, I've had that. Okay, whose turn is it? Your turn, because it was just mine. Okay, you do these problems. No, I do not want to leave. Ready to move on, so let's do these. First step. Subtract, oh, I have to stop. Subtract 2 minus 2 minus 2. 5w equals 5. I know, sometimes my handwriting is really, really horrible. One of my issues, I get it.
I just forgot to write all the...
Okay, so I subtract 2, and the second thing I do is divide by 5. 5, w equals 1. On the next one, my first step is to add 5. So I add 5, k over 3 equals -9. And then what do I do next? Multiply by 3. Times 3, k equals -27. Yeah, sometimes I even have to stop and think. It's not quite going for me. Let's move this up. So what's my first step on the next one? Multiply by 2. So times 2, d minus 6 equals 22. And then I add 6. ADD 6. D equals 28. And on the next one, my first step is to add 4. So I add 4, 2/3 v equals 13. And then I multiply by 3 over 2, the reciprocal. Three over 2, those cancel. V equals 13 over 1, 13 times 3 is 39 over 2. I do believe that's correct. Is that what you guys got? 39 over 2? Or did you wait for me to do it so you can write it down?
I wrote down the explanation.
No, I say that because I have kids that will like, oh, I don't want to do that in my hand. I'm going to wait till he doesn't write down the answer. Like, we know that. They're like, but he won't be able to know I did. Yeah, I know that. Here's some more. Do those. So let's do this. So on the first one, which we have been talking about, but it was not recorded, but we have been talking about, our first step is to subtract 6 subtract 6, and I get negative 3x equals 0. Now, to solve this, I divide both sides by negative 3, sorry. Divide by negative 3, negative 3, negative 3, x equals 0. You cannot divide by 0, but you can divide into 0. 0 divided by a number is 0. The other thing to understand, and this will also be very important later on, is if I multiply two things, and negative 3 times x is multiplying negative 3x, if I multiply two things and I get 0, one of them has to be 0. Negative 3 is not 0, so that means x has to be 0. Okay, that's actually a very important concept, that if I multiply two numbers and I get 0, at least one of them has to be 0. It could be both, but at least one has to be 0. And that's going to be huge later on for us. Okay. What's my first step on the second problem? Subtract 7. Negative 18. And then what do I do now? Multiply by 3.
Oh no, I just got this not accurate, but he got his out.
K equals. All right, gentlemen. One of my rules about eating and drinking is it must not be a distraction. It's becoming a distraction. All right. So negative 18 times 3 is negative 54. Yeah, I can do that. Okay, the next one. What do I do first?
Multiply by 6.
Multiply by 6. So do times 6 times 6. Move it up to make it easier on me. F minus 5 is equal to 4 times 6 is 24. And then what do I do? Add 5. Easy peasy. Add 5. F equals 29. I like that. Okay, next one, what do I do first? Subtract 3. Minus 3. Minus 3. 1/4 y equals 2. And then my next one, I multiply by what? 4 over 1. The reciprocal of 1/4 is 4 over 1. But I can also think about it as being just plain old 4 if I want to do that. Either way, it's okay.
It really depends if you're multiplying by a fraction.
By 4 or 4 over 1. Either one is okay because you'll get the same answer in the end because they are essentially the same, two versions of the same number. The only way to treat it differently is if this side was also a fraction that was not 1 over, then I would do that. So I get y equals the 8. Okay. And is there any more? Nope, that's it. Ooh, hey, awesome, awesome.